Hello everyone. Present here virtually, I am Nalini. Here, and I welcome you all for today's session, which is titled as Exploring Data Science and Its Applications. And presenting this session, we have with us our today's expert, Dr. Dillip Rout. Dr. Dillip Rout is an alumnus of IIT Bombay Ph.D. and currently working as an assistant professor in the Department of Computer Science and Engineering in Centurion University of Technology and Management. He has contributed in a couple of advanced research project of national importance at IIT Bombay, and also was a postdoctoral fellow at Indian School of Business, Hyderabad for a couple of months. He possesses a very diversified experience working at academic, scientific, and industrial R&D units for last 11 years after a graduation. B.Tech in Information Technology, gold medalist from IIT New Delhi. His area of interest includes network optimization, graph algorithms, data science, and machine learning, digital transformation, and automation. In addition, he has got his work published in some journals, international, national conference, and workshops. You can start now, sir.
Yeah, thank you very much, Malini, for such an introduction. So I will be talking about some of the things of data science and application today. So basically, there is a lot of confusion. Also, there is a lot of interest, and there is now a lot of train going on regarding this data science. So let us discuss an overview of that. I'll be just giving a high-level overview what the data science consists of, and what sort of applications we can have, and why people are really interested for such kind of career, and so on and so forth. All right. So before going into the details of each of the segments, so let me tell you that whatever I am going to present, so that is not word to word matching or definition, rather a high level overview. And since this is a changing field, I mean, this is vastly and very fastly changing. That is why we can say that this definition that I'm going to giving, or whatever words I'm going to use, may not be matching what you Google, okay, afterwards or at the simultaneous position. Okay, so with this understanding, let us begin our talk. I'll be taking about 30 to 40 minutes. In between, we'll have also some questions. If you are interactive, that the session will be very interesting for us. All right, so there are three things basically I'll talk about. One is background, then what about the introduction to data science and the analytics part, and will summary. In summary, we'll conclude everything. And in the background part, as you can see, there are three different aspects. One is the application, second is science, and third is data. So if you just imagine this title, I mean, if I go by the title, in the title there are three words basically, okay? Data science and applications, okay? So these three words that we are going to break it in these three words, and we'll look into details what are over the all of those, okay? So I'll go from right to left, breaking each of the words, factorizing each of the concepts one by one. So I'll go for applications first, then we'll look into the what are the science in data science, then what are the data in data science, okay? So with this, we'll just move towards the next step. That is, what is that data science? So if you look at the data science, you Google it, you'll find such kind of thing. This is nothing but a word cloud of the data science. So you can see a lot of words are combined here. So information technology, computing, processing, modeling, branding, etc., machine learning, vision, computer vision, engineering, big data, mathematics, visualization, statistics, etc., etc. There are a lot of things out there. So as you can imagine, so all those things are falling under data science. So if you wanted to have a brief of the data science, then this is what we have. But Not necessarily you have to be expert in each and everything of it. Of course, you have to learn some of those and find out one thread of the data science. So let us understand more with the next couple of slides so that we'll break down what data science means. So as I said before, so let us first look at the application. So nowadays, many of you are going for the online shopping. Mostly of you are going for the online shopping. So there you might have seen this recommendation systems. Okay. In the recommendation systems, what happens? Suppose you are buying from the Amazon. Okay. So we are searching for books. So automatically you are searching one book of one particular title, but there are multiple books will be suggestion, which is other type. Suppose you are searching for the book for the data science, but some of the books from the DBMS, some of the books from the algorithms that will also shown to you. And the irony is that if you are searching to you, Amazon will or Flipkart will recommend something else. And if I'm searching, that will also give me some other recommendation. That is because of the personalization. So it Amazon or Flipkart, they know where what we're searching over the time period, so that they know that yes, that will be for this user, this might be the liking. For that user, that might be the liking. Okay. Similarly, after you buy a product, actually, so after buying a product, suppose you are buying a cloth, so automatically it is suggesting some more products also. You might be interested to buy a bag. You might be interested to buy a cord of to phone recharge, etc., etc. So these are all AI based, and these are all recommended systems. So that is one application. The other application, that is the personal assistant. You may be aware of Alexa and Siri. So both are all our personal assistants. That means whatever you do, Alexa, please play the music. Okay, please stop the oven. Or Siri, just switch on the fridge or switch on the AC. So all these things are nothing but the personal assistant. But look at what is in the background. So you are actually giving a command in case of sound. Okay, so that sound has to be converted to text. After that, machine will be converted into binary format, then only the machine can operate. So there are a couple of phases here. It's just not one straightforward thing, but you should understand what is going to happen. I mean, speech to text conversion, then text to command conversion. That is happening. Then only it is doing something. So the way we understand human beings is not the same when the machine is going to understand. So in that aspect, we have this personal assistant. Okay. So another example is the ARVR, which is gaming, which is what is that? Augmented reality and virtual reality. So you can see here, if you wanted to wear these glasses, so actual position is this, but the players will be realizing as if they are inside the environment totally. Okay, they can feel that they're fighting. Okay, you might have played such games. On the right hand side, these people are playing volleyball. Actually, these people are not inside this screen, but they will be wearing some kind of devices which will be giving them virtually that they are actually playing, and whatever force they are using, that force will be actually used to that volleyball. Yeah. So that is the virtual reality we have. Okay, another application is that automated vehicle. So now you can see that automated vehicle is that there are multiple devices, multiple sensors will be there, multiple cameras will be there in that, and out of that you can see that is on the road and it is making a decision. You can see that it is looking left, right, as we look as a human being, left, right, then drive, also look into the look in the traffic lights, that is also it aware of. Okay, so that is what been given in that format, that this has been AI powered, and this is there is something special thread is there of machine learning, which is called reinforcement learning. So that has been used here. Okay, that means it will be learning through test and trials, then making some errors. After the errors, there will be penalty. Then after the penalty, it will improve the algorithm. Okay, so these are a couple of applications that we have seen so far. Okay, and if you look at what we discussed is that what is the following of the application of the AI? We can say recommended systems by Amazon, Flipkart, or virtual reality games. If you look at it, actually we have done both. Okay, so the answer D is correct. Okay, so out of those data science and applications, so we have covered applications so far. Now we'll cover what is science, then we'll cover data. Okay, now this is the crunch part of all of those, that what is the science behind it. So before that, we have to understand what is the difference between AI, what is the difference between machine learning and deep learning, big data, and data science. All right. So in a nutshell, I'll say that AI is the paradigm or one of the concepts that we are going to give some machine intelligence. That is why this is called artificial intelligence. But machines are not inbuilt intelligence. Your radio, your smartphone are not intelligent by default. But you can see that Alexa and Siri, they are given some intelligence. So they can make some decisions. Okay, what we are giving in words or what we are saying in sentences, okay, while talking, okay. So they can convert it. Similarly, Google Assistance is there. Okay. So that can also convert our words. So those kind of intelligence we have to produce, okay, which is not inbuilt, just like the animals or humans. So some intelligence we have to give it to the devices. That is what meaning of the artificial intelligence. And it's a broader picture. Okay, that is why, maybe knowing the Venn diagram, this is the broader set. Okay, topmost set. So that is also the end product also. That is what we mean by artificial intelligence. And in case of machine learning, okay, machine learning is one of the parts of the artificial intelligence, and which is responsible for all kind of algorithms that we are using in the application, okay, in the application of the machine learning, because without algorithm we cannot do it, right? So that kind of thing we should know about this artificial intelligence and machine learning. And coming to the deep learning, yes, deep learning is also a specific part or specialization of this machine learning, where there are a lot of data is there, and there are a lot of uncertainty of the data is there. Also, there is not understandable data is there. So what happens, this machine learning kind of algorithm, we have to combine, not one algorithm will fit into it. We have to combine many algorithms to do it. And also there will be many more iteration of it, several, let's say thousand or maybe in millions. So those kind of iterations are required, okay, to do the deep learning. So that is why this is called a deep learning. But remember, this deep learning is a subset of this machine learning. And coming to the big data, as I understand, so there is nothing, the small data is coming, so there is a big data. So I'll disclose it big data in after a couple of minutes. But just understand, there is a huge data set. Just imagine how many data is produced in Google per day. So if you guess it, it will be 20 petabyte kind of thing. And 1 petabyte is 10 to the power 6 gigabytes. Okay, so you can imagine that 1 terabyte is there, your hard disk may be. So it will be something 10 to the power 5 times of your hard disk. Okay, per day. All right, imagine how many hard disks or how many storage space is required. So that is the big data is about. So we'll also discuss more about it. Then coming to the picture is the data science. Okay, so what exactly is data science is doing? Actually, data science, if I say, this is a philosophy. Okay, this is an art or philosophy which is combining all these concepts and producing something good output. Some product output is there, product orientation is there, or software is there. Okay, that concept is nothing but the data science. Okay, and if you look at the right hand side, it is more or less the same, except that this big data is coming picture here, so which I like it, because big data is also having something more out of that data science or machine learning kind of thing. Okay, so here you can see this circle is nothing but your data science circle, which is combining data mining as well as data modeling, which is also written as data science. Okay, so the same thing I have written over here in text format, and I'll be happy to answer if any questions. You can, of course, give it in the chat box so that I can refer to it later on. Okay, so coming to the next slide, that is what is science in data science. Okay, so one part I have described all the words. Now we have to look at why machine learning is famous. So this is about the machine learning, what the different strategies machine learning is using, why people are crazy about it. Okay, so to understand that, we have to compare between traditional software development as well as machine learning. Okay, these two things we need to compare. So we always know what is the traditional software development or software programming is there. Okay, we have to write a program, the data is there, maybe we have to operate on something on the data, then will feed to the computer, there in the computer the program as well as the data, then the results will come. Okay, this is the general style where how you do it. And the traditional one is hard coded logic. We have to write all the programs starting from beginning to end. Then it's noise free data cannot be handled. Then it's algorithm driven, or it's more like a deterministic kind of thing. Okay, but when you compare the machine learning, it is completely different. Okay, so what is different is there. So in the machine learning part, we can say that this is the desired result we want. There is some training data. Okay, and there is some modeling. There is some modeling we have to say, some model or some algorithm we have to adopt, and we have to train this data. Okay, sorry, train the model with that. Some model we have to say, let's say artificial intelligence, artificial neural network. So that we will be taking as example. Then we have to train with this data. So after the training is over, okay, the training is over for this model. This model, just please focus, this model will produce one program. Okay, and now this program is ready. So whenever the live data is coming or the actual test data is coming, it will make some predictions. Okay, the predictions can be different kinds. Let's say classification is there, whether he is a boy or the person is a boy or male or female. That is the one of the classification example. Or we can say that what is the market value today, that is the prediction, that is called regression normally. So that we can do, or else we can go for a reinforcement learning as well. Okay, so those kind of things are different. Now you can, if you compare, here in the traditional software development, we are actually programming it, we are writing the codes for it, the program. But here we are developing a model. Okay, developing a model and training the model with training data set. Okay, then the program is written by the model, not by us. Okay, that's the basic difference is there. And what is there, it can also handle noisy data. Okay, it can also handle noisy data. That is, there is some errors in the data, it will handle. Our model is capable of handling them. But when your traditional software, this program is not capable of handling noisy data, mostly not. Okay, so this is very transient, and this is data driven. That this is a algorithm driven. Which one? Algorithm driven is this one. Okay, and the second one, machine learning, is data driven, because without training the model, it will not produce the actual desired output. So that is why more and more data is required. If you, even if you start learning about the machine learning, the data science, you need a huge data set. Huge means at least 1,000 lines of data sets we need. Otherwise, your machine learning algorithm may not work properly. Okay. So there are some questions over here also, which is following is true. Machine learning is subset of deep learning. Artificial AI is subset of deep learning. Deep learning is subset of machine learning. Artificial intelligence is subset of deep learning. Actually, the C1 is true. Okay, I'm right. So in between, we have paused something. If you guys have any questions, please put it in the chat box so that I can see that. Anybody typing in the chat box any questions? I think the chat box is empty. All right, so we'll move ahead and we'll look into it. What is the data in the data science part? We have, mind you, that we have covered what is application in data science, what is science in data science, and what is data in data science. Sorry, science and data science. These two we have looked into. We are moving from right to left. Okay, now we have to move and look into what is data in that. Okay, so the data part. This is the data part. So in the data part, normally why it is difficult, or why what is so big in that, I have mentioned that about the big data. Okay, so each day Google is producing 20 petabytes of data, which is quite huge, and this is 10 to the power 5 of the 1 terabyte kind of thing. Okay, which is really large. Okay, so in that case, the volume is coming to the picture. There are 4 V's normally in the data, but some people write 3 V's, some people write 6 V's also. So in the big data, that is one of the things, that what is the volume of the data. Okay, this is one of the V's. So I have given the example. Then I'll also say that there are different varieties of the data. Okay, so we have text data, numeric data, text data, that like the sentences, English grammar like sentences that we have. Also we have audio, we also have video. Okay, such kind of data is there. Sometimes the live data is also there. So there are really different varieties. So this is the second V. And the third V is of the velocity. Yes, if you imagine how the trend is changing. Suppose you take the example of you. In one day, you may be chatting in the WhatsApp for at least 3 to 4 hours. You may be spending, and how many messages you are spending, maybe in other social networks as well. And if you look at your Facebook, so once you log into it, that is at 2 p.m., then you find that this is the home page, this is the wall, what this is the trending is going on. Okay, at 3 p.m. you log in, you will never find the what is the content of the 2 p.m. will not be visible, because that will be old one in one hour only. Okay, you can imagine how much data is stored there. Okay, so such kind of thing is the velocity is really high. The data is changing every time, and it's really vast, and this is live. I know due to the internet kind of properties, we have the ability to send, receive many kind of data. So that velocity is really high. So we need to take care of that. This is the third V. The fourth V is the veracity. Yes, once the velocity, volume, and varieties are more, then veracity will be more. That means the uncertainty in the data. Like you are having a transaction in the IRCTC website. Okay. So since there are many transactions, your transaction may not be correct. It might fail. Your ticket booking may not be happening. Okay. So such kind of things might also arise in that. So that is the veracity we have. That is one example I have said. Sometimes your mail is not going, not due to the problem with the internet, but may be due to the problem with the Google site. Okay, that may happen. So we need to actually actually change that one. Okay, actually, I mean, resolve that one. Another thing is that suppose you are playing, you might have got a subscription of Amazon Prime. So, or let's say better will be moving to Sony Live. In the Sony Live, you are having a live match. So in the live match, that you might be seeing, observing there is some disturbances in the live live matches also. Sometimes you may not see the screen, but the audio is coming. Sometimes it's the reverse. Okay, sometimes the quality is degrading. Why? Because of this veracity in the data. Okay, that we should also handle in case of big data. Okay, and but this is the fourth V. And why I'm saying big data? Because imagine that I wanted to measure your BMI. Okay, BMI that used to how healthy you are. So you need to have your height and weight. These two things are needed. But if you imagine the big data, I mean, we know what we need, and that is why we'll collect only height and weight. So then we'll calculate the BMI. But in case of big data, what happens? We are storing many data without knowing that what we are going to model or what we are going to calculate. But we just store it day by day or hour by hour. So that is why this is also big data. It's not just the size only. Okay. So coming to the structure and unstructured, we one of the V's is variety. So this variety we look into it. What is structured data and what is unstructured data? In the structured data, we have almost all the things are defined. There is a schema for it. That means the title is there. Suppose in the Excel sheet you are writing name, roll number, and mobile number. So my name is Dillip, then roll number is 2, then mobile number is 98 something. Okay, all these things are there. So that header is there in the Excel. That is called the schema. Okay, so that schema is available when we are talking about the structured data, and there is a native relationship. That means suppose I take a number 10, I take another number 100, I can compare which is larger, which is smaller, which will come in ascending order, which will come first, in descending order, which will come second first. That we can always decide. Such kind of data is the structured data. That is called the structured data, which is known and which is normally operate. And previous to this, up to last 2010 or something like that, we used to operate only about the known data or the structured data. But nowadays other data, unstructured data, is coming in the picture more, and we are addressing those. Okay, what is our unstructured data? One of the example is the text. Okay, if I have said some sentences right now, just right now I'm saying some sentences, can you compare with the other sentences which I said just 10 minutes ago? There's no direct comparison, right? Greater than, smaller than, okay, divided by 2, the mathematical relationship, all those things are not directly, cannot be compared. And which nouns I have pronounced right now and which nouns I have pronounced 10 minutes ago, can you compare why I have pronounced? It's difficult, right? Similar thing if you are watching a movie. Okay, so whatever happened at 30th minute of the movie, Can you directly compare with the whatever happened at the 60th minutes of the movie, that scene and this scene? There may not be no relationship, right? Or maybe they are related, but it is hard to describe the relationship. So in such kind of thing, we said this is a unstructured data. Okay, so this NLP is booming, and this is a computer vision, which is improves the computer graphics, image processing, video processing, etc., etc., audio processing, all those things. They are also booming. I mean, people have not looked into it much more. So those kind of data is there, and this kind of things are also collected without any motive. Okay, and finding a native relationship in the unstructured data is very, very difficult. So, but unfortunately, the unstructured data is 90%. Okay, unstructured data is 90% in the world. The structured data is only 10% because these are processed or semi-processed data. Okay, so we have to deal with that. That is why the big data is coming. Another aspect of the data is the different types of data that we are going to look into. So the different types is, one, we can say that categorical or qualitative data. Another is numerical quantitative. So numerical quantitative is very easy. So these are again different two types, discrete and continuous. The continuous is 1.1, 1.1.2, something like this is continuous value. Discrete is 5, 10, 20, like that. These are all discrete or discontinuous data. Okay, and in the categorical part is there are nominal, there is ordinal. Nominal means my name, your name, water, air, sky, etc. Those are all names. So those are nominal data. And then ordinal data is good, bad, average, excellent, etc. Although these are words, there is a meaning to it. Okay, you can imagine that excellent is much better than good. Also, average is better than bad. Okay, so something like that. We can, if we order it, I can always give bad as number 1, then good is 2, average is 3, then this excellent is 4. I can give a weightage to them. Okay, those are all ordinal or data which are helpful in ranking cases. So these two things are there. Okay, so we need to also take care of that. Okay, so I'll not go to the details part. If any questions, I will really happy to answer. Is there any question in the chat box? No, I don't think there is any questions. Okay, so again we are going back to the pointer. So we'll go to into the jump into the data science part, and we'll look into the what are the analytics we require. Okay, so these are basically three different kinds of analytics that we have. Business analytics, normally we say one is descriptive, another is predictive, another is prescriptive. So in the descriptive part, we have that we will be analyzing the data only and try to find out what are the pattern of the data, what are the insights of the data, how the relationship stands. So those are all descriptive things. Normally the statistical parts comes here. Okay, and what is the predictive? That we say that today weather is this much, the temperature is this, and our last 2 months the temperature is this per day. Then what will be the temperature for next day? That is the prediction. Okay, so that we can do. I mean, that is what the different kinds of analytics. And what is the prescription? Prescriptive is that, look, we have 10 shops. Okay, sorry, we have 1,000 rupees. Okay, I wanted to buy 3 products. So which is the optimization of that? I mean, what is the best value that I can spend for each of these products? So those kind of things can be decided with the prescriptive done. This is also called a operation research or optimization kind of thing. We have linear programming there, non-linear programming there. Okay, so many things are there. And in case of predictive analysis, we have all the machine learning algorithms, including the time series. Okay, regression, classification, time series, clustering. Okay, recommendation systems. All right, so those kind of things will fall into this predictive analysis. And descriptive analysis is doing some statistical analysis, max, mean, average, okay, median, etc. So having said that, I'm not going to details of over it. Okay, so we can always look into it later on. So that is, well, okay, let's go to the data science part, how it looks like, what is the vocabulary of this, and what are the framework for it. Okay, one is, yeah, one is there is that input will be there, some specification is there, then processing will be there, then the output will be given. So this is the general format of any programming or any system. Okay, So we'll look into the data science vocabulary. What is that? Features. What do you mean by features? Is simply the columns or the metadata. In front of the title, heading of the columns and the metadata. Okay. So these are the features called. Then observation, the values and the cells. Then the response is nothing but the output variable. These are all features are also variable. So one of those will be the response variable or the output variable. Okay. And the label is the category, column, etc. What is existing or not. Okay. Those kind of things are labels, the naming part. Okay. And what is that fitting? We have to build a model, then find out the suitability, what is the accuracy, etc. This is the accuracy we need to, and matching efficiency, etc. we can find out. So for example, here we have the data. So these are all the features we have. Okay. 1, 2, 3, 4, 5. Okay. So out of these, suppose let's say salary. We have to predict the salary. Given all these details of the employees, we have to predict the salary of the next employee. So what, for example, the employee number 6 is having age 20 and he's having qualification as BSc, number of experience is 0. Then what should be the salary we can fix it? So that we can decide upon this prediction. Okay, depending on this previously given data and finding out a model for it, for finding out an algorithm for it. That is what we want to do in the data science part. And if you look at the data science life cycle, it starts with here, then business understanding, what the business logic is there. Then there are two different threads are here. One is for data acquisition and understanding. Okay, data acquisition means we have to acquire the data. So I have some slides for that. We'll discuss there. What are the data source, how the pipelining, then what are the environment, some wrangling, exploration. That means some pre-processing of the data is given here. So that is what we need to do. Also, we have to go for modeling part. Then what is the modeling? Feature selection or feature engineering. Then model training is there. Then model evaluation is there. After we train the model, so we have to test the model. So that is the name of the model evaluation. After these things are over, then only we can go for the deployment. Okay. So these two things are, what is that, why they are also related, because we may go in parallel, but sometimes the data comes in some pages of the data, we have to test it with the model again, other data comes in, we have to test it again. So these two things go one by one iteration till we find a good model, good fitting model, which will be run, which can be done with this model evaluation. Okay. Then after we settle down, then we have to go for a deployment. Deployment can be at the customer end. Okay. Or else you have a website or something up data up, then you are posting it. So okay. So there we can also check regularly what is the score, performance, monitor it, and if there is changes, we can always go back and remodel it according to the data. Okay. That is how the data science life cycle works, and finally there is the end to it. Okay. And if I look at the different stages of the data science, data acquisition, data wrangling, then data exploration, then modeling, then evaluation. These five are in general. People might say you something also, also there are more steps, but this much is enough, okay, to understand. So if you look at one, that how the acquisition works, the acquisition will be finding out the different sources of the data, then finding out the data actually. So for example, I say go and find out what are the age of the each person in your locality. Okay, how do you find out? They might be using some social network, they might be having some email, from those you can extract, or you can go there and have a physical survey on that you can also do it. So there are multiple things. So from that we have to find out what are the different features, that is data profiling, we have to do it, and which features are important, which are not. Okay, all these things. And basically we need to also go for web scraping. If I have to extract from the Facebook, or we have to extract from the Gmail, etc., etc., or LinkedIn. Okay, and after that we have to go for wrangling, prepare the data for the processing. Data cleaning is there. If there is missing data, if there is null values, how you're going to treat it. Okay, and next phase is the data exploration. Data exploration is that investigate how the data is related to each other, what are the different pattern is that. We'll discover the data and go for some descriptive statistics, mean, median, mode, and variance, standard deviation, etc., etc. These are the something, and through the visualization we'll understand more. So that is why data visualization is also important and one of the part of the data science. In the modeling part, we have forecasting the future by prototyping, then feature engineering, parameter tuning, etc. Okay, so all these things are the modeling part. Then the next part is to how to evaluate it. Okay, so measure the efficiency and the accuracy of those data. So validate it through the actual data, then deploy it, execute it, and quality of service you can measure it. So out of that, so in my previous slide, I have shown something called data mining. So these three are nothing but the data mining part is coming. Okay, sorry, this not the acquisition, but these two are data mining part, and then data modeling part is these two, so 4 and 5. Okay, so with this understanding, we'll go to the next phase. And there are a couple of questions. Of course, if you're interested, you can always answer. So I have already told this is a data-driven thing in summary, and this is an interdisciplinary field. Okay, this is mainly a philosophy, or we can say this is one of the art. Okay, and there are a couple of things are involved in the data science steps. Then what is in the conclusion, I would like to say that this is multidisciplinary end-to-end solution. Okay, enterprise decision making. Okay, then next is data science domain. There are the beauty of this data science is that even if you don't know about the domain means, I mean, e-commerce, national, international cyber security, and this is business analytics, engineering, production, anywhere data science can be used. Healthcare, sports, politics, transport, Internet of Things, etc., etc. But the beauty of the data science that without understanding the details of this domain, also you can utilize. That is why people are crazy about data science. Okay. So there are what are the different roles of data scientists? We'll see in that. Okay. Next slide. Then what are the different skills you need? You need mathematics, statistics, data analytics, then solids programming skills is required mainly in Python or R or one of these. Of course, SQL we cannot also skip. That is also required. Okay. Then some machine learning algorithms you need to know. Then some data mining techniques, data storage techniques, and management, etc. And these are some of the couple of career opportunities we have. Okay, and as we have discussed all these things, what is acquire, transform, then explore. Okay, all these things are different segments, parts of the data science modeling, BI tools, big data. Okay, so these are all the parts of the data science that you can refer to while thinking about the career opportunities. BI tools means there are something called Power BI and Tableau. And there are many more also, which will give you some data analysis. Okay, not data modeling, but rather than data analysis through visualization. So those things are different. Suppose you are making a plot. Suppose you have the all the edges of the several members. Those edges you are plotting in a graph. So those kind of thing can be automated, or there are some menus are available which can be done with BI tools. Okay. So looking at the career, we can be a business analyst. Okay, there is data acquisition will matter, and also data exploration will matter. And this BI analysis normally from some MBA or non-technical background, non-engineering or non-technical background, they can use some BI tools. They can be called business analysts, but they have understanding of the business as well. Okay, other cross, wherever you say cross, this is not mandatory, but company may ask for it. It is good to know, but these are the wherever you see a tick, that means this is mandatory for a this position role. Data analyst, both you have to know acquisition, also you have to know the this transformation. Okay, how to transform the data, how to explore the data. Okay, all these things. Then maybe you are also using BI tool. For data engineer, this is the big data part. Okay, your acquisition, transformation is required, may not be required exploration, but you have to handle the big data as well. Okay, then for the data scientist, you can see all the things that matters. That is the different. Okay, for you have to be all-rounder for a to be a data scientist. And for machine learning part, you need to know this. Okay, that data exploration you need it, then modeling you need it. Mostly the machine learning engineer will spend so much of time in the modeling part. And these are a couple of good sides if you want to explore the data science. Okay, and machine learning part, you can explore those. So I am done from my side. I'll be really happy to answer any questions if anybody is having. Yeah. Over to you, Malini. Malini, it is over to you. If any participants would like to ask any answer. Am I audible? Hello.
Yes, sir.
Okay. So I don't think that in the chat box there are any questions. If there are questions, I'll be really happy to answer.
1 minute. Thank you so much for this very informative and demonstrative session, sir. We will ask our participant to put your question in a comment box. We will try to provide the answer by Dr. Dillip Rout below the comments. Thank you so much all the participants for our active presentation. Let me know inform to all. This complete session will be available on our Research Circle YouTube channel. So if you want to watch it again or want to share it to somebody, please do visit the Research Circle YouTube channel. Thanks, and last but not the least, thank you, Dr. Dillip Rout, for taking out the time for session with our. With your permission, I would like to end this session, end today's sessions here, sir. Thank you, sir.
Yeah, thank you, Malini, and thank you to the Research Circle for giving me this opportunity. And yeah, I'll be happy to be called again. Yeah, thank you. You may end the session, please.
Thank you.